Welcome. It's an honor to be here. But first of all, I want to know why I have to go after the radioactive guy that has the green glow still on the back wall. So, I'm not quite sure why I was chosen for. I know I'm a rookie at this, but okay. So again, I am honored to be here. And for the people that know me, they're probably laughing inside because Richard Mest has never done a presentation for 30 minutes. 30 hours or something like that. So anyway, again, I'm honored to be here, and a lot of my colleagues are here. I do want to start by saying that well water is the safest water on the planet. And when you follow the presentation that I just did, you don't feel very warm and fuzzy about that. But I just want to reiterate that truly groundwater is probably the best option that this country has to bring safe water to Americans. Nothing against centrally piped systems, but they're challenged to maintain quality in their infrastructure. And I'm not going to beat infrastructure dead because we've all heard enough about that. But please understand what we share in forums like this are really good. Sometimes it can portray the water source as being less than appealing. But I'll challenge anyone to prove that groundwater isn't the safest water supply that we have on the planet. And the professionals of NGWA, the professionals as part of Water Systems Council that are certified to bring that safe groundwater to the end user, they go through a tremendous amount of education to do what they do. So again, I just want to promote the groundwater industry, promote the fact that private well water is awesome, and most of the time is a tool that's underused. And I'm hoping that the federal government, and it trickles down to the state government regulators, understand that maybe spreading a pipe 10 miles from a central system might be better served by providing independent wells at a safer water quality. So what I'm going to talk about is something pretty cool too, called nitrate that's going to hurt you. The benefit of what I'm going to talk about is that it really impacts a small part of the population. Nitrogen is really vital to our metabolism. In nature, 78% of the atmosphere is nitrogen. We get a lot of nitrogen, obviously, in drinking water from runoff and things, but we get nitrogen through the food that we eat. That's how we get a lot of our nitrogen in our system. So this slide just sort of shows nitrogen source. And nitrogen, as I said, is essential. If you have excessive nitrate, it upsets oxygen transfer in our blood. And hemoglobin is changed into metahemoglobin, and that creates problems for a small part of our population. We're going to talk more about that. Healthy liver really maintains the balance. I kind of like that you made that screen bigger. The rumor was that it was too small to read, so thanks for helping me out. Oh, is it?
Yeah, so you can have it this way.
No, I'm good.
You can have the full screen.
No, I'm good. Problem of overconsumption. I didn't know my site was that good. Thank you. So, yeah. So the older people don't have a problem. It's really a fetus. It's a developing child, and it's a child that's 1 year of age or less. And if you have excessive nitrate in the water supply, it creates the blue baby syndrome. So basically, it's starving of oxygen. Now, because of the small population that is exposed to the threat, it gives us a lot of options in how we handle that. And you've heard conversation about terms like point of use and point of entry. And really what we do as a water treatment professional is not only do we have to diagnose what's in the water, and by the way, one of the questions that Tanya, the question asked, and I want to clear this up. So if you have a water treatment professional testing water that also wants to sell you a solution, is that a conflict of interest? And it's not, because if you're a member of Water Quality Association, you sign off on a code of ethics. And we enforce that strongly. So we are concerned about having that separation. Also, what I recommend to any water treatment professional is when you have a health-related contaminant, that you get an outside opinion. So for me, it's easy to test nitrate in a home, but I would prefer to have a third party prove that the nitrate's there, especially after I've installed treatment to reduce it. I think it's important to have that separation. I think for maintenance, you can rely on the water treatment provider to confirm performance through maintenance, but I really believe to identify the contaminant and to assure that you're compliant, that you solve the problem, I think having a third party, especially with health-related contaminants, is critical. So when you look at nitrate levels, you know, a lot of us think about livestock. We think about waste. We think about runoff from farmland, and I know it's that time of year, and man, I got the whiff of agriculture driving home yesterday because I live in the country. They're really fertilizing the fields right now. So, and anyone close to the Chesapeake Bay understands nitrate and what that's done to the requirement of advanced on-site waste treatment because of nitrate runoff. So nitrate, everyone has a map, so I figured I'd have a map. So when you, aren't they cool? Yeah, so, you know, nitrate is prevalent really where there's farmland. So you see in the central part of the country, you see a lot of nitrate. And quite frankly, what I recommend to consumers is that, again, if it's a young couple that is buying a home and has a water source, and I really don't care if it's a centrally provided one or not, they should be concerned about certain things, and one of them is nitrate. So you sort of don't wait until you're pregnant to worry about nitrate. You sort of look at that and be proactive with that. We tend to see higher rates of problems with pregnancies in the central part of the country because of excessive nitrate. So it's a real concern. EPA limit is 10 milligrams per liter. Some of us still use parts per million. Nitrate as nitrogen, NO3, and then there's nitrate 1 milligram per liter as N, nitrate. So testing. There are test kits out there, and again, I think that you have anything from strips to comparators to mini spectrophotometers you can carry around. At the end of the day, they should be treated as indicator tests, and an independent certified lab should verify. So to me, these test kits are great, but they're really designed to indicate a problem and for maintenance of the system. So let's look at treatment technology. So again, when we evaluate the contaminant, we have to understand how it reacts with you. So one of the questions Steve received was about the volatility of arsenic. You know, we look at that. As a water treatment professional, you really have to understand, is it an ingestion issue? Is it a topical issue? Or is it an inhalation issue? And then what part of the population is impacted by that? And then what conditions would they be presented with? So example, if nitrate was volatile, I'd be concerned about inhaling it. Fortunately, it's not volatile. So we don't have to worry about taking a shower and getting it that way. It's not topical. So I don't have to be concerned about taking a bath in it. But I do have to be concerned with ingestion. So there are 3 ways to really treat for nitrate. There is distillation, there's specific resins, and you've heard Steve did a great job about anion, cation. I'm not going to, we'll talk a little bit about that. But there are selective resins, and resins are polymers. So they're petroleum-based. They're powders that are formed into a polymer bead, and then they're manipulated. They're manipulated in a way to attract particular ions, minerals or metals that have an electrical charge to them. And then you have membrane technology, in this case, reverse osmosis. So with distillation, I don't know how much distillation is actually sold today. It's a small percentage, but I still wanted to include it. So basically, when you heat water, that's water treatment. And in New Jersey, with the water quality that Steve shared, and it is bad there, plumbing fixtures try to be water treatment, right? So in New Jersey, in southern Jersey, try and find a bathtub that's not brown, because the bathtub's trying to treat the iron. It's doing it through aeration. A water heater in southern New Jersey is going to be filled with iron, because part of treatment is heat. So with distillation is simply using heat as a treatment device. And it's heating the water to the point where it creates evaporation. Evaporation, then, is where you have the separation. So with distillation, you're going to end up at the heat transfer spot or location. You're going to precipitate all the minerals or the metals. In this case, it would, along with those, would be nitrate. And then the vapor is going to be pretty close to very low TDS water, 10 milligrams per liter or less. Quite frankly, this is a hydrologic cycle, right? This is Mother Nature. Mother Nature takes a liquid, evaporates. Unfortunately, we've created so much pollution in the atmosphere that now water treatment professionals have to understand the chemistry in the air, right? And a lot of us know a little bit about chemistry, but an acidic water-based solution is going to be a little more aggressive. So you talk about concerns in your geologic formations. If the water source coming down as rain is hungrier than ever before, the contamination is going to be worse. And then in a drought, we have concentration, which even makes it worse. So being in water treatment is a great idea. If any regulator wants to change their profession, water treatment probably is what you want to look at. So distillation has high energy. Distillation can be a little complicated, but it's a great tool because you get some disinfection along with that. Anion units, so the resin-based systems, again, the resins are polymers, so think of baby powder that's then formed into a bead. And then that bead is manipulated to have certain characteristics or affinities for contaminants in the water supply. So we have two different types of resins that we use. One is cation, and a cation resin is actually negatively charged, not the magnet thing, but electrically charged, so it is going to draw cations. So a water softener is going to draw positive things, and Steve hit on them, calcium and magnesium, which is hardness, iron, the metal of iron, the metal of manganese, and radionuclides like radium, forms of radium. So the cation resin is what you typically see. Anion resin is more selective, and anion resin is very, very particular. One of the things I want to share is that anion resin hates hardness. I want to repeat that. Anion resin hates hardness. You will foul your anion select resin really, really fast if there's not adequate pretreatment. So on the cation resin, you have to have an exchange, because this really isn't removal. This is exchange. So we're taking one thing and we're replacing it with something less harmless. So with a water softener, the resin typically starts with sodium on it. You can use potassium chloride as a salt or regenerant, but potassium isn't as efficient as sodium. So depending on your contaminant, like if you're dealing with radionuclides, you definitely don't want to use potassium-based salt. You want to use sodium-based salt. On the anion side, it's totally reversed. So it's a positively charged media to grab onto anions. So the anion of choice is chloride. You know, this resin, we are literally bastardizing this material because these resins are designed to be in the hydroxyl form. So water softener resin wants hydrochloric acid. And anion resin wants hydroxide, sodium hydroxide. That's what it wants. Well, you can't put that in a house or this hotel because of the corrosion that would occur. So we end up making it take sodium or making it take chloride. So it works well, and I have to put on my sort of industry defense hat here because I tire sometimes of people saying water softeners are no good, ion exchange resin, they dump salt. What chemical can you use to clean something that you can eat, right? This is edible regenerate chemical that we're talking about here. It's not bad for you. So when you look at the resins and you have your standard cations and your standard anions, nitrate is one of the anions. So what we're going to do is we're going to use a resin to actually draw nitrate to a pore. And when you look at a resin bead, I'm oversimplifying this, but think of like a golf ball. A dimple is a site. That site has a capacity. And once you fill every dimple, you have to do something with it. As Steve said, depending on the contaminant, this is baseball season. So imagine that you have 3 baseballs in your glove, and someone throws you one more. Can you catch it? No. It's going to fall, but what's it going to do? It's going to knock some baseballs out of your glove. That's making ion exchange down and dirty. It holds so much, and depending on the contaminant, when you have too much on a dimple and another one comes in, you can knock it off. There are some resins that are more selective, fortunately, and that's what the anion resin is. So the anion resin is basically going to it's going to be bombarded by hardness and iron and things like that, but it's really going to go after nitrate. But it's also going to want sulfate, and it's also going to want alkalinity. So your anion unit looks like a water softener, acts like a water softener, and regenerates like a water softener, but it's using the different part of the salt to clean. Now, it's important to take a look at the ratio of sulfate to other contaminants because our equipment today isn't able to zero in to a particular contaminant. So there's a lot of competition. So anion resin is great for whole house. So if I want to treat for whole house, this is what I'm going to select. Now, my contamination is based on ingestion. So, and it's an infant. So a lot of times you don't need whole house treatment, but the industry seems to be drawn into providing that as a solution. Point of entry is the best is anion exchange resin. Again, if you're an educated adult, you just watch the baby in the bathtub and you don't let them drink bathtub water and you're probably okay. But we can provide the solution with a whole house or whole facility with anion exchange. There will be competition with sulfate, so the capacity for nitrate is huge. It's gigantic, the amount of bed volumes that you can get through anion resin for that. And then you regenerate it with salt. It uses the chloride form of the salt, doesn't use the sodium side of the salt. So what we add in the process of nitrate reduction is chloride to the water supply. Fortunately, the amount of nitrate we're reducing or exchanging for is so low that the chloride that we add is minuscule. Now, the issue becomes if you have sulfate-laden water. So for the regulators here, if you have high sulfate in your groundwater, you want to be careful about using anion exchange because you could exceed the MCL for chloride through this exchange process. So the thing we look for is the sulfate load, and if your sulfate is very low in concentration, anion exchange is a good technology to use. The negative part, it will drop pH and typically a point, but corrosion is very misunderstood in our industry, and alkalinity itself is totally misunderstood, unfortunately, in our industry. So it's job specific, but you can typically bet on about a point pH drop. So then you might need post-treatment. So anion exchange, if you have iron, if you have manganese, if you have dirty water or turbidity, if you've got high hardness, you have to have a water softener first or some type of iron reduction, or you will foul your anion resin. I do not and will never promote mixing a coffee can of anion select resin into a water softener. It's doing a disjustice to the industry. So when you look at anion resin, you want it to be by itself. You don't want it to be a blend of something else. That's called mixed bed DI, and that's not what this conversation is about. RO. RO is a membrane and is really versatile. So RO technology, if someone calls you and they can't pronounce the contaminant on the phone, just say RO. Because RO is our best tool. If you can't pronounce it, it's carbon followed by RO, right? Raise your hand, professionals out there, right? GAC and RO. So if you get that crazy 20-chain PFOA or you get a volatile you can't pronounce, hey, GAC followed by RO, you got to cover it. Absolutely you do. So one of the benefits of RO is its ability to grab so much. The negative is that it grabs so much because you can't dial in and say, I want my TDS to be this. You know, take the nitrate, but leave some of the other stuff. We can't do that. So you strip it, and then you control adding. That's why Coca-Cola tastes the same around the planet. That's why Starbucks tastes the same around the planet. They use RO technology to strip it all out and control the recipe going back in. So reverse osmosis is a really tight membrane, 0.0001 micron, really, really small. But imagine, so I'm watching my time. How am I doing, like 4 minutes?
You have about 8 minutes.
Oh, 8, cool. All right. I know it's me or lunch, so.
Or if you take less, you'll have time for
Yep,
questions.
no, I'll be good. I'm almost done. So if we look at this, so if we turn around and look at that door is 1 micron. If you look at this wall, that's an RO membrane. So imagine, and some of us that are older, the Fruit of the Loom commercial, you know, so imagine all of us are minerals. We're lead, some toxic stuff, nitrate, and we're running around the room in this water-based fluid, and we get thrown against that wall. It's not going to take long for us to fill the surface of that wall. Well, once you fill the surface of the wall, then we become the filtration media, which means it gets tighter and it gets less productive. That door is a 1 micron. We can all fit through that. So we're not going to be an interference or make it a better filter. So with RO, imagine that's the RO membrane, and then I have someone with a kick-ass fire hose on that wall. So when we all hit the wall, that fire hose blasts us and rolls us off the wall. That's what RO does. So RO is semi-permeable. It's sort of like cellophane that we all use at home. The soup doesn't come out. Well, we control what goes through, and we use pressure. There's osmotic pressure everywhere. For every 100 TDS, there's 1 pound of pressure osmotically. So if you want to reverse it, you have to be careful about pressure. So the higher your mineral concentration is in your feed water, the more pressure you need to exert against the membrane to actually make it produce water at the quality we want. So there is a penetration of the membrane, and then there is a flushing of the membrane. There are technologies that are brutal. Some small systems can dump 6 gallons of water to make one. Some can dump a half a gallon to make one. So you're seeing a lot of advancement in the membrane technology. So RO works really, really well. I guess I should have showed all these, huh? Sorry about that. So RO membrane technology is a really tight filter. It takes out a lot of stuff. It's more than just micron filtration. There's a lot of other stuff that goes on the surface of that membrane, but it works well. As Steve said, they're relatively inexpensive. Back to what Eric Yegi talked about, make sure the product is certified and make sure the certification is real and not counterfeit, because there is a huge problem in the water treatment industry of offshore products coming in with a fake label. So to conclude with this, nitrate's a problem for an infant and for a pregnant woman because of the fetus development. So you want to at least control drinking water. You can do whole house. Drinking water can be distillation. I prefer RO. Whole house would always be anion exchange. So with that, I'll take some questions.
Great, thank you.
Do I need to do this?
All right, so we do have some questions, and I'm going to just go through them. And okay, so the first one is, can you comment on nitrate, nitrite, and possibly ammonia as an indicator of other forms of contamination?
What I think of right away is microbial contamination. So that's where I would go. I would
Sure.
use them as a surrogate for septic leakage or fertilizer runoff.
Okay. In my state, 94% of our community water supplies use groundwater. So how are those supplies less safe than private wells? Getting to your first comment.
Yeah, well, I think private wells are the best solution for the best water quality on the planet. And I think if it's a central water supplier, they have protocols to follow. So the water source really shouldn't matter.
What about recent studies that have found nitrate levels 5 to 10 milligrams per liter increase the risk of colon, kidney, ovarian, and bladder cancers, and risks increases for people with low vitamin C intake, high consumption of red meat, and for smokers?
Yeah, so one of the things, when you talk about food, there are a lot of meat products that are very high in nitrate. And I think one of the issues that we have is sometimes water quality is the lowest hanging fruit. And we don't look at the nitrate level. You get more nitrate ingested by eating a hot dog than you ever will drinking water. So I think that health is very personal. So my immune system could be totally different than Steve's. So 1 milligram per liter of nitrate might impact me. So this is kind of hard to answer, but because it's very individualized and toxicology is always changing. So you tend to see levels getting more strict, not less.
Are there any concerns about RO systems concentrating these pollutants and then flushing them back in the environment?
Yeah, so that's a really good question. So I want to make sure everyone understands that water treatment medias or devices do not create the condition. We concentrate the condition. So Mother Nature sees the same amount. We just transfer it out. So, and there's a difference between treatment and remediation. Remediation is capture, hold, incinerate, or do something. That's not what water treatment is. So Mother Nature, if I collect 100 parts per million of nitrate all day long and I dump maybe 5,000 back, if my device wasn't there, Mother Nature's still going to see 5,000.
Now, at least for community water supplies, that's not quite true, because if they have to get rid of, they have RO, it's considered a hazardous waste, and they have to depot. Yeah.
Well, no. So yeah, absolutely right. So there are certain regulations where absolutely the RO membrane concentrate is a concentrate. So if you want to include a little bit of remediation and treatment, then you would have to capture that and reprocess it. Yep.
Okay. Do you know if softeners are harmful to? Okay, we're not going to answer that question.
Oh man, I'm the best person to answer that.
Eric's talking about it this
he's the
afternoon.
second best person to answer.
Well, we're going to take the second best answer.
Okay.
Then. Okay, so using RO, how does a homeowner put back the necessary ions?
Cartridges. You can get selective cartridges that are on the marketplace that fit into any cartridge housing.
Okay, and the last one we'll take. In Minnesota, nitrates and pesticides are found together. Advice?
GAC and RO.
All right.
What a way to end,
All
huh?
right. Thank you.